Welcome to the UEFI Forum webinar. We'll begin the talk here shortly. Hello and welcome to the UEFI Forum webinar, Firmware as a Service, Enhancing BIOS Security and Flexibility, presented by Lenovo. Our presenters today are Kevin Wu, Principal Engineer at Lenovo, Albert Gao, Senior Engineer at Lenovo, and Talen Liu, Senior Engineer at Lenovo. I will turn it over to our presenters to begin their talk.
Hi, hello everyone. Good morning and good evening to all BIOS engineer and firmware experts. Nice to meet all of you here. I'm very glad to talk with you on this webinar. The topic we're going to share today is firmware as a service, enhancing the BIOS system security and flexibility. The topic we're going to share today is, we are driving the firmware package as a service-oriented delivery sense. So here is a brief information about the presenters. Myself, my name is Kevin. I'm focused on the firmware architecture design, and my teammate Albert, Lenovo senior engineer, and Albert focus on the firmware architecture design, the code-based design, and some UEFI tools. And Talen, he focused on technical implementation about the FaaS architecture modules, and also he has many design experience on some UEFI tool sense. So here is the agenda. To better understand our design logic, we have a simple outline here. It looks very simple. We have major three portions. Why, what, and how. The why is focused on the background. I will explain some detailed information why we wanted to do this. There will be some background information sharing about the firmware as a service. And my teammate, Albert Talen, they will follow up with details, what and how. Why we wanted to do the firmware as a service? What kind of the key factor driving this? So here is the background. Let's start by looking at the current industry situation. It is kind of a very common scenario for BIOS engineers. We design the firmware and we release the firmware and then shipping with our product. At the same time, we do see a lot of requests on firmware customization sense. And the firmware customization looks more and more important for many reasons. But, everything has two sides. We see the significant opportunity on firmware design, but at the same time, we also facing the big technical challenges since. On the opportunity side, we see this is an increasing demand for our large enterprise customers. They have a request for wide ranging of firmware solutions. This is driven by the need from our customers. And our large enterprise customer, they do want to have some, advanced firmware functionalities. And most of their requests are something about the system level security and the manageability sense. Uh, as we all know, the UEFI uh, code base, the EDK2 support many standard features. The UEFI framework does offer a bunch of free libraries, like the capsule update, the secure boot, the network boot protocol. We can support the HTTPS remote boot since, and many other best protocols. All of this can help our firmware designer to build lots of firmware functionalities. Uh, for example, some customer may have a strong, interest on Wi-Fi connection during the post. Maybe you have the, curious why we need to connect the network during the system power up. This can be utilized as a device authentication for secure secure digital workspace. That means before the power on, you can authenticate your connected device. So after we implement this function, we can we can satisfy our customer with such secure design. However, all this kind of technical implementation come with big technical challenges since. One of the primary issue we face is that the limited size of the BIOS flash zone. It's very difficult to support a growing number of the feature within the limit size. Uh, you know, uh, Furthermore, when we customize these features, we must ensure that the system of flexibility, because large enterprise customers, they have also strong request or for easy deployment sense. So here is a typical case I can share is that sometimes the customer A want the function A, but the customer B wants function B. But the tricky thing is that sometimes the function A and the function B are some kind of the conflict. For example, uh, some customer wanted to use their own operating system. Most of them are Linux based, and they request that the UEFI firmware must include their boot key only. All other boot key must be removed for security reasons. In the traditional firmware design, uh, we only allow user to update the whole system image. Then after that, the user will get what they want for the new version. But from the user side, it cannot select the feature one by one. Uh, but if we looking back the OS level application, user can easily any application. We are trying to install the firmware function, just like install the OS level application. So and we treat the firmware function as a standalone module. We called firmware as a service. When we install some firmware functions, just like install the new software in the system. If our customer wants the cloud system recover things, he just install this dedicated module. So considering the complicated firmware customization situation, we already seen. So that's why we bring this firmware as a service concept to UEFI community. This is where firmware as a service comes into play. By moving the firmware solution to a service-based mode, we can offer better firmware solution to our users and improve the UE by our design. And my teammates, Airbot and Talen, they will have more details explanation. So Airbot will cover the whole technique, architecture design. Uh, yeah, thank
Thank
you,
you.
Airbot.
Okay, thank you, Kevin.
Okay, let me introduce what is FaaS. Generally, when considering a service solution in the PC field, they typically means we will offer customer with either hardware or software because customer can request various hardware configuration and software application to meet their specific needs. Actually, firmware is linked uh, both hardware and software. So firmware can play an important role, uh, which hardware or software can't meet. If we can customize the firmware and provide the feature in a similar way to hardware and software, we will able to meet a diverse user needs, especially for the enterprise customer or SMB small business customer, right? Okay. First, as a revolutionary concept, it reimages firmware-level functionalities as a modular, service-oriented offerings rather than these static, monolithic BIOS components. Under this concept, users are empowered to select their desired firmware features from a website or an app store or from the OEM app portal. Uh, Customer can raise up their request, right? Then we can try to meet them from the firmware level. Therefore, under the concept of FaaS, BIOS is no longer responsible for booting up the system and initializing the hardware device. Instead, similar to hardware and software, it can serve as a source that provide users with functions such as maybe device management, anti-theft, or data protection. Okay, and next page. Okay, FAST is not just a theoretical concept. It presents a series of practical technical solutions. Technically, FAST is required to offer a solution that enables its feature module to be deployed as independent plug-in modules, maybe through the cloud. Moreover, the architecture of the FaaS should be well designed to ensure uh, compatibility with a wide range of UEFI modules and numerous feature providers. FaaS module can be um, maybe just like snapped together, just like the uh, Lego bricks, allowing a customer to freely combine the FaaS function blocks into their customized solution. This is to say, in the framework of FaaS modules are designed to be independent. These modules are developed to support user customization requirement, such as tuning system performance, lock special hardware configuration, establish the application whitelist, along with the other relevant aspects. Furthermore, FaaS architecture must exhibit a high degree of flexibility. It should be able to incorporate feature modules from OEM or IBV or OSV. Additionally, it needs to facilitate the seamless integration of third-party UEFI modules. Here are some user scenarios of FaaS modules. Uh, First, customize user logo. Uh, a FaaS module can be installed in the end user system to change the post logo, right? According to their preference. This module can be developed by OEM. The next one is cloud system recovery. This module allows the system to boot to a cloud server to download the OS image, driver, or application, right? It can be provided by OSV. Actually, this feature is provided by Microsoft. Next one, second web UEFI module. This module is used when end user want to recycle their system. They want to remove the data, which is generated by themselves, right? Cycle web module can be developed by OEM, IBV, or third-party providers. Firmware can also play the important role as a root of trust, right? So maybe some popular the AI application or large language model need to be bounding on your personal system. Uh, or some customer sensitive data need to be protected. They can use the firmware security solution. Okay, next I will hand off to Talen, who will introduce the detailed design. Okay, Talen, please.
Okay, thanks, Albert. Next, I will introduce how FaaS is designed, why FaaS can overcome the challenges we encounter, and why the design could meet the target requirements set by the concept of FaaS. Let's turn to page 7. On this page, we will delve into the high-level implementation of the FaaS architecture. As previously mentioned, one of the primary objectives of FaaS is to offer a flexible design and a convenient way to install and upgrade FaaS feature modules. To achieve this goal, we leverage the capsule update technology defined in the UEFI specification. In the context of FaaS design, one or more FaaS modules can be bundled into a single capsule package and subsequently published to the user side with the cloud. Typically, in a standard capsule update implementation, a single type of firmware, along with its associated FMB driver, is packaged into a capsule for cloud-based update and then installed in corresponding device. Please look at the diagram on the left. To support the capsule update of FaaS modules, we have defined a special flash layout and individual FaaS management module. First, we create a dedicated FaaS region within the BIOS flash. This FaaS volume is exclusively used for storing FaaS modules. Additionally, due to the limited size of the BIOS flash, some FaaS modules can also be stored in the hard disk ESP partition. Next, we define a FaaS management module embedded within the system BIOS. This module plays a crucial role in installing and launching the FaaS modules. Consequently, the entire process for installing a FaaS module is as follows. Please look at the diagram on the right. First, develop a standalone UEFI feature module and create a capsule package. This is to design a standalone UEFI feature module based on user demand or some user case, and package the module into a capsule. Second, publish a capsule package. This is to make the capsule package available on the cloud. The third, install the package on the user side. FaaS modules will be installed either in the dedicated FaaS volume or in the hard disk. Let's turn to page 8. On this page, we defined the protocols employed during the installation and loading of FaaS modules. Given the inherent complexity of these protocols, a comprehensive and detailed description is not provided here. Nevertheless, through this introduction, their functions and optional process will be clearly presented. Generally, we define two primary protocols for FaaS module management. First, FaaS module install and update protocol. This protocol is utilized for the installation of FaaS modules in capsule mode. It verifies the information of the FaaS module to be installed, determining whether it should be placed in the BIOS flash or the hard disk. The second, FaaS module dispatch protocol. This protocol is responsible for launching the existing FaaS modules during the BIOS post process. From the perspective of protocol execution, the overall process is as follows. Once a FaaS module is installed in the system, and the system enters capsule mode, the FaaS module install and update protocol is invoked to install the module into the BIOS flash or the hard disk. During system boot, the system BIOS initiates the FaaS module dispatch protocol in the early post process. Subsequently, this protocol launches the existing FaaS modules through the user interface. Let's turn to page 9. As previously mentioned, in the design of FaaS, a dedicated FaaS region is required to store FaaS modules. The following details the layout definition of the FaaS volume and the information related to FaaS modules. Please look at the FaaS volume portion on the left. Within the FaaS volume, there are two main components, volume header and module storage. FaaS volume header, this part contains the volume signature and the module count. The signature serves to identify the FaaS region, while the module counter records the number of modules that have been installed in the system. Module storage. It is designed to store FaaS modules. Each FaaS module consists of a header and a body, where the header records essential information about the FaaS module. There are several rules governing the module information stored in the BIOS flash. The first, unique list requirement. This means there should be no duplicate headers or modules, which implies that each header and module should uniquely correspond to a specific FaaS module. When a new version of a module is installed, the older one must be removed. Second, optional presence of module body. The FaaS module body may not be necessarily be present in the BIOS flash, since the module can be stored in the cloud or on a hard disk. The third, mandatory storage of module header. Regardless of where the FaaS module body is stored, whether in the BIOS flash or on a hard disk, or even in the cloud. The module header must be stored in the FaaS firmware wallet. Please look at the FaaS module header portion on the right. The following table concisely outlines the definition of the FaaS module header. Gate. This is used to describe each FaaS module. Every module should have its own gate. Size. It indicates the size of the module body. Type. This parameter is utilized by the FaaS module dispatch protocol to determine how to initiate the FaaS module. Storage. It records the storage location of the module. The FaaS module installed protocol will refer to this information to decide where to store the module. And the dispatch protocol will use it to determine where to launch the module. Name. It is a string that appears in the BIOS user interface and also serves as a file name on the hard disk. URL. This parameter specifies the cloud URL and is used by the dispatch protocol to launch the FaaS module via HTTPS boot. Okay, the above is the FaaS technical design introduction. Next, Kevin will help provide a comprehensive summary of FaaS. Thanks, Kevin.
Yeah, thank you, Airport and Talen. I will give the brief summary about this innovative idea for the firmware as a service. As you may see, we have a detailed architecture design sense and very detailed technique implementation. So on this page, we have a brief summary. As you can see, the first one, well, this architecture, FaaS, offer a high degree of firmware customization for user because you can install the firmware function one by one, just like install your software. It absolutely can improve the UE through either through the customer website or OEM portal. User can easily select the functions they need. So easy select and easy update to user. This is very important from our customer perspective. They just need to click what they need, and the new version firmware can be easily deployed to the target machines. And the second point I want to highlight here is optimization. The FaaS architecture offer optimization for both user and our firmware developers. It allows the user to easily update their firmware by the cloud or in software portal. But more important, it's also some kind of the optimization to our developer. Uh, uh, by saying this, our developer can focus on standalone module design. That means more customer centric. In the traditional way, our BIOS engineer spend a lot of time on board level debug, but now we're gonna to move to our customer needs. I think this is more important to our user. So our developer can dedicate to the functionality sense, and then release their design with a single UEFI standard binary file. So when they release the file, they can just post or release their UEFI binary to the cloud or to the software portal. We can imagine if everyone develop firmware in this way, it definitely can enhance the system flexibility, because it's also very good to our UEFI community. This is some kind of the new approach to writing the firmware code. And the third one, the last point I want to highlight here is we can see we always see many security vulnerabilities comes up. It looks endless since for vulnerabilities. We keep receiving many security things. Our customer need to push our engineer to release the security patch things. So if we can design the vulnerability fix as a single module update, just like the operating system level can be fixed, only one binary to our user. That will be benefit everybody in many aspects, even to engineering resource or easily deploy on our customer side. And this FaaS architecture also will bring some flexibilities, especially to IT administrator. They will be very easy to update their systems. The FaaS module, when the FaaS module was designed as a standalone EFI module, it means it's some kind of the common sense. It will across the product line, it will across the chipset platform. So, and also promotes the reusability. You can reuse your code from the product A to the product B, even can cross the platform, because we wanted to set up the abstract layouts from the hardware and the product, and also easy to maintain. This is some kind of the efficient integration for the new firmware into the new systems. So all above is what we share today, and thank you for your time. I believe there are many things we need to be addressed and big room to improve the design. But I truly believe this is a single step to the long journey. We hope we can enrich the UEFI community by everyone together. So that's all for today, and welcome any free technical questions or the discussion. Yeah, thank you, Samantha.
All right, thank you, Kevin. Our first question here says, can we create a search text box in VFR forms to find an enabled setting on the main page or other pages? Just to repeat that there, our first question is...
Can we create a search text box in VFR forms to find an enabled setting on the main page? Yes, we can create a search text box in the BIOS setup. Maybe on the main page, you can search some BIOS setting. Yes. Okay. Any other question?
Our next question here is there any FaaS interface to boot validation of the FaaS module?
So, is there any FaaS interface for boot validation of the FaaS module? Currently, the general idea is we will use the cycle boot method when we run some FaaS module or FaaS application, we will verify the signature of the FaaS module. Yeah, just looks like the second boot method. Yes. Okay, next question.
Our next question here says, how can we verify the set of modules one selects are actually compatible and work together?
Verify the side module. So,
Yeah, I think for compatibility check, this is truly important. You know, when we design the FaaS module, when we look at the design phase, I think we need to make sure the individual FaaS module should be running very well on pure UEFI shell environment, and then we're gonna do some system compatibility test. That the key concept for FaaS design is all this is module is some kind of a cross platform. So when you release the FaaS module, you must to make sure this module is running smoothly on pure UEFI environment. And I think if you can keep the compatibility about of your module on the UEFI environment, that should be fine. But there is still some, debugging things, troubleshooting there. Yeah.
Our next question says, how might we guarantee that a module's dependencies are also included?
Okay. How to guarantee the module's dependency include? Yeah, this is also key concept for how to design the FaaS module. The background is, when we include all the independency, the code size will be, some kind of a huge, there is many external library need to be claimed. So in the FaaS module design, you'd better to include all the dependency in your single UEFI standalone module. That means you are not going to deliver the EFI file. That is a full function module. Only in this condition, you can guarantee your quality of your deliver package sense.
All right, our next question says, Where is the URL where we can create the FaaS packages? Is this a URL available openly on the internet?
Yeah, I think the URL is available on the public internet, or you have a private network. That's depend on your design. You know, the UEFI base protocol support the HTTPS boot, right? We can redirect the target file, remotely in somewhere, maybe the remote server. You can specify the IP address over there. So this is depend on your design. If you wanted to uh, open your linkage to everybody, then you're gonna to open the permission for everybody can access. But this is really, some kind of a security concern here. So when we use the code to access the remote file, we suggest you set up some kind of authentication mechanism. You have to check the some maybe the certification file or your username and the password, because this is very critical to our customer, especially to enterprise customers. So I think this can be durable as long as you set up some kind of authentication mechanism. Then you can guarantee uh, who can access your remote file.
That's all the time that we have for questions today. Thank you again for joining today's UEFI Forum webinar, and thank you to all of our speakers.
Yeah, thank you, everybody.